What?
Do you hunt?
Do I hunt?
Yeah.
I hunt gophers sometimes. I didn't say that out loud. I do not hunt.
You should. It's fun. Try it.
Do you hunt, Matthew?
Sure. Yeah.
I don't. I actually. I think if I went hunting, I think I would. I don't have anything against people who hunt. I think if I did it, I'd really feel bad. I think I'd feel
Yeah.
sad for the
Here's
animal.
my thing. I feel like
But you don't feel bad when you eat a burger.
when you kill an animal, and you eat it, I feel like there's more purpose to that. It's like you understand what that animal had to go through. You took its life. But like when you just buy a
No.
burger from like anywhere, you don't really
Hey,
understand.
man.
Because
Hey,
you
man.
basically don't waste the animal. You use it in a, how would I say it, a good way.
Right.
Yeah. Instead of eating sad animals that are walking around in a dairy just waiting to be slaughtered, you're changing the market, going to like the free animal who's alive.
Mm-hmm.
But I don't kill any animals. I get my burgers from Winco. So I just feel bad for Winco because I'm taking stuff from them. I don't I know it's sad that I'm taking from Winco. So anyway, should I just keep rambling or should I get on and see? You
We
guys
should
are
take
talking
a
about
field trip to hunting. We should go hunting on a field trip.
should I do that for honestly,
Yeah,
who would
say we
who
should.
would if I did can I do Google with a GoPro camera
I would go.
and would you guys like and I do it like a reality show and I'm just like have like the grass in my and I'm like okay I'm gonna hunt my gopher, you know what I mean, and then I like go and I get the
I think
gopher and then I don't know,
I
I
think
get
that'd
my
be really
hose and I put it in the hole and I'm okay I'm gonna flush him out, then the gopher comes out, right, then I'll see the cute little gopher and I'll say oh I feel so bad and then I'll just I don't know, throw the gopher in my neighbor's yard or something like
I
that.
feel like you've killed a gopher before.
You know, I'll do let the gopher go. I'll call it catch and release. I'll catch the gopher and I'll release him again. Be for sport. I won't eat him. I won't eat the gopher. I promise. Okay. So, all right. I'm just rambling. Let's get to work. Okay. What am I doing here? I'm looking for my. Okay. So here's a couple things, you guys, we need here for notes. You got to we're going to talk about logarithms. Let's see what I have here for my title. I had it written here. Let me put it here so you guys can see.
I have a question. It's related to math.
Okay.
Why is there no 5.3? We did 5.2 yesterday.
Yeah, because it was graphing, and we decided to eliminate graphing log functions. But I was thinking about doing that, but I don't have time to fit it in. We're cutting stuff out. You know, am I presenting? We're cutting a lot of stuff out because the semester's so short, right? So, but it's graphing logarithms, Ariana. That's what you're missing out on.
Okay.
Okay, so here you go. Assignment number 32, 5.4, page 279. And then it's going to be, here's the title, is Solving Log Equations. I should say simplifying more, but solving log equations. You can write that down. No. Okay, so can I move it? Can I leave that? I'm going to move this in 10 seconds unless someone says, no, sensei, wait. 5, 4, 3, 2, 1. You know what I'm thinking? What about rats? If I have a rat in my house, would it be okay to kill the rat?
Of course.
Well, yeah, it's affecting you.
Yeah, so I don't know. Anyone not? I don't know. I just don't know because I did have a rat in my house, and I hate rats. I kind of have to be honest with you. I should tell you how I killed it, but I'm not going to talk about that. No, I should. No, that was actually a story, man. Oh, I should tell you about the dead rat in my car. That was the worst. I didn't kill it. It died in my car. Oh my gosh. Does anyone ever have a dead rat in their car?
No.
Nah.
Imagine. No, okay. If I have time, I'll tell the story. If you guys want. You guys probably just want to get out of here. I'm just
Just tell
seeing
the
class.
story.
No, I can't because we got to get this done. Half of you just want to get out of here. You want to be done. It's Friday. Friday. No, not upload. 5.4 self-practice. Boom. And here we go. We're going to talk about now, really quick. You guys, let me just show you something really quick. This is Godzilla time. You guys know how you like Godzilla time. Where are the notes? Godzilla time. Real quick. X to the 5th times x to the 3rd. Someone yell out, what does that equal?
X to the 8th.
X to the 8th.
Can you
Weird.
see the title page real quick?
What's that?
The title page. Can you
Title
show
page.
it? Yeah. That. Let's take a picture.
You know, I'm gonna get to this in just a second. Let me finish my Godzilla time. I'm gonna get to this in just a second. We'll go back to it. So real quick, x to the 5 times x to the 3rd is x to the 8th. Weird, because we've talked about this. We're multiplying, but we're adding, right? Right? By the way, why is that? I'm not even gonna show you why. Let's just keep going. X to the 9 divided by x to the 2. What does that equal to?
X to the 7.
Thank you. X to the 7. We subtract. Weird. We're dividing, but we're really subtracting the exponents, right? You guys got that?
Yeah.
Now, I can show you why if you want, but I'll do that after class if you really want to understand why that works. But we've talked about that a million times, so I'm not going to talk about it now. Okay? Now, there's something called there you go, Kayla. It's right there if you want to see it. The product property. Okay? Now, what the product property says, if I take log b m and n, right? Notice when the m and the n are next to each other, what's going on there when they're next to each other?
They're multiplying.
Yeah, they're multiplying. I can change that as long as the base is the same. I can change it to log bm plus log bn. And it goes with the exponent rule when I say when I said what we said before, it's kind of the same idea as this. X to the 5th times x to the 3rd equals x to the 8th. I'm multiplying, but I'm really adding. So I can multiply these, but I can really add them too. Okay, because these totally equal the exponents. But anyway, nevertheless, after all that, if that doesn't make any sense to you, just know log b m times n equals log b m plus log b n. A lot of times we like to see numbers. If I say log 7 3 times 4, I can change that to log 7 3 plus log 7 4. Okay, that's the product property of logarithms. The product property. That is for the multiplication. What is opposite of multiplication?
Division.
Yeah, so guess what? You guys know this product is the sexy word for multiplication. Does anyone know the sexy word for division? Quotient. Okay, I'm gonna get rid of this product property in 10 seconds unless someone says.
Can
They
you
need-
give it like 30 seconds?
Sure.
Product is a fancy word for what? Multiplication?
I said sexy word, but thank you very much. But yes, multiplication. Dun, dun. Product usually we associate with the answer to a multiplication problem, right? Product. Sum is addition. Difference is subtraction. Quotient is division. The quotient property. Ariana, can I move?
Yes, you can.
Alrighty. The quotient property is just like we said here before. 9 divided x to the 9th divided by x to the 2 equals subtraction x to the 7th. Same thing with the quotient property. If I have the base b, m divided by n, I could say log bm minus log bn. Whoops, the wind blew. So if I say log 710 divided by 2 is equal to log 710 minus log 72. Okay, I'm going to remove this in 10 seconds unless someone says. 5, 4, 3, 2, 1. The last one is called the, it'll still be there a little bit. I'll just move it up. The power property. Power. Power. Okay? What that means, if I say log b m raised to the n power, I can take that n and put it in the front. Let me do one with numbers. If I say log 7, 3 to the 2, see how that 3 is raised to the 2 power? I can change that to 2 times log 7 to the 3. I can just move that 2 down. Usually there's an x there. I should put an x there, but that's what the power property is. Power. Dun, 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 dun. This morning make the call. The one that ends it all. No, 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 no. Not for the money. Not for the power. Just for the truth. Dancing the eye of the eye. I'm gonna switch this in.
What's that letter or number before the log bm dot?
This one?
Yeah, what's that?
That's an N. This is an N.
So it's n log bm.
Log B, M as in Mary, N
Equals
as in Nancy. What this is saying, Kayla, is I can take this N and I can move it down there to the front. This is the same equation. I can just move the N. Remember, the N was here. I can move it down. Does that answer your question?
yes. So it's gonna be like n times log bm.
Yes. Exactly right.
No.
Okay, I'm flipping it. I'll 10 seconds unless someone says something. 4, 3, 2, 1. Okay, now this is called the, let me write it better. It's the change of base. Change of base rule. Change of base says, I can, remember this is the base right here. The C. I can take log base CA. I can change the base to whatever this B is by going log BA over log BC. I'll do that with numbers in just a second. I'll do an actual hard case problem for that, because that's the kind of a cool one. You'll see how that's very practical. This is specific for your calculator. So let's say, let's do a very easy problem that we can do in our heads, but let's pretend we don't know the answer to this. Let's say we have a problem that says 2 to the what power equals 8. Even though we know it's 3, can I use a logarithm to solve for this equation? And the answer is yes, I can. Let's write it in log form, right? So let's put this in log form. So let's change it to log. And this is on the left. Put the log on the left. My base is 2, right? And I put my equals. You guys remember we did this yesterday? Then I can take my 8, my x, flick ink, and I can switch them. So I put the 8 here and the x there. Now I have a log equation set up for me to solve for x. The problem is, am I going too fast? Let me know if I'm going too fast. Okay, no one say anything, so I'm going to keep going. The problem is, in my calculator, this dang log button is a log base 10. I need a calculator. I mean, I don't need a calculator to solve because we know the answer is 3. But if I do need a calculator, this has a log base 2, son of a gun, right? This has a log base 10. So I use the change of base formula to change this into a 10. And this is how you do it. I write this, so I want to know what log 2 to the 8 is. I want to know what that is. So I go like this. Change of base, if you look here, notice the A goes on top and the C goes on the bottom. So the A is the 8 and the C is the 2. So it's log base 10, 8 divided by log base 10, 2. Remember, we don't need to put the 10 there. So all you have to do in your calculator, remember my answer should be 3. All you have to do is just go log, remember, can you see the 2 there? Log, wait, can you guys see? Dang it. I feel like I can't see. Can you guys see log? I don't know. Log 8. Can you guys see my calculator? It's like all dark. Shine my cell phone light on it.
Kind of.
Okay, log 8 divided by log 2, right? That's what I did. Log 8 divided by log 2. Can you guys see that? Log 8 divided by log 8 right here. Log 8 divided by log 2. Log 8 divided by log 2 equals, and there's my answer, 3. Can you guys see that? 3. So anyway, that's how you do it. And we're going to do those with the homework. Let's get on the homework. Are there any questions before I move on to the homework?
So that's
Let's move on.
X equals 3.
What's that?
What's gonna be x equals 3?
Yeah, x equals 3. log 8 over log 8 divided by log 2 equals 3, which makes sense because, right, this equals that. Hang on a second. This equals that because I changed to log formula, but I need a log base 10, so I use my change of base to make it equal that, and then I got 3, which makes sense because 2 to the 3 equals 8. A lot of steps, but when you do it a couple times, it's like, you know, this is easier than English. Okay, that's the change of base. So I'm moving on. Let's do number 3. So number 3 is kind of a weird problem. I'm gonna go like this. Okay. So they give us these numbers, so you might want to write them down. I don't know. Number 3, they say log 7, or open, at least have your, I don't know if you can have your, well, here, I'll write it down. It says this, log 7 base 74 equals 0.712, which it does. And we say log 712 is approximately 1.277. Okay, so we now have those two things. That's what they tell us. Okay, number 3, they say figure out log 7, 3. Okay, so you guys with me so far? So we know this, we know that. They're saying find log 7, 3. Well, I don't have log 7, 3. I only have log 7, 4. I have log 7, 12. But using division, I can say log 7, 3 is equal to, bear with me here, log 7, 12 divided by, actually, let me write it a different way. Sorry. Log 7, 12 divided by 4, right? Log 7, 3 equals log 7, 12 divided by 4. Look at your quotient rule now. What does your quotient rule say? I'm going to ask, so because I think you guys are sleeping. You want to sleep? More exciting talking about the dead gopher, huh? Let's go with Carlos. What's the quotient rule say?
To subtract?
Yes, quotient rule says I can change the division into subtraction. So I can change this into log 7, 12 minus log 7, 4. Quotient rule. Look at it. Should I pause so you can think about that? Log 712 is 1 point, so log 712 is right here. It's 1.277. Log 74 is right here. Log 74 is 0.712. So we just need to subtract them, and that's all you've got to do. .565. That's 3. Let's do 5 now. Five is asking, hey, what's log 7, 16? Well, log 7, 16 is equal to, what can I multiply to equal 16? Okay, what can I multiply to equal 16? No wrong answer here, but Brandon, what'd you get? What can I, but there's no wrong answer, but there's a better answer that can make our job easier. Brandon, what equals 16?
Like what multiple you get 16?
Yeah, multiple product.
There's 8 and 2.
Okay, that doesn't help us because I got a 4 and a 12 that I need to work with.
4 and 4?
4 and 4. Yes, very good. Brandon said, hey, log 7 is equal to, log 7, 16 is equal to log 7, 4 times 4. Okay, now let's change that using the product rule. Okay, so change it using the product rule. I'll call on one of you guys. Go ahead and do it. I'm going to look at my list here. Change that using the product rule. Okay, I'm going to give you 15 seconds because I want my weekend to start. Yeah! So I can look at my phone some more. Get off my computer and go watch a video. Get on my Instagram. Okay, Gracie, how would I change this?
Would you change it to log 7,4 plus log 7,4?
Very good. Okay, is it still there? Okay, what is log 7,4 equal to, Jay?
I got 1.4 or 1.424.
Jay just answered it all right up because he's just the man. What Jay did is he said log 7,4 is equal to 0.712. Log 7,4 is 0.712. So 0.712 plus 0.712 or 0.712 times 2 is, what did you say it was? 1.424? Is that right? Is that what you said, Jay?
Yeah.
Okay. Any questions? I'm gonna do this one gave me a hard time. I had to stop after class to do this and solve it with the students because I did not understand this one.
Can you go back to the answer?
Sure. Certainly. I'm gonna wash that man right out of my hair. Gonna wash that man right out of my hair. Honestly, this gopher is tearing up my lawn, but I just can't freaking find him. He like makes holes and then he fills them up. I can't find a good hole to get him. My lawn's not really that neat anyway, so it's not really a lawn. It's more like a dirt yard, so I'm not too worried about it, but it's just the fact that he's in my yard. It just bugs me. Okay, let's do 7. Okay, 7's kind of tricky because these are only numbers I have, and they want us to use 1/4. Move over here so that you don't have the glare. But I can change this to log 7. 1/4 can be written as 4 to the negative 1. Does that make sense? I got my 4. No? Well, whenever we write an exponent in negative, you can write it as the reciprocal. Like, for example, I could say, right? You guys should know 3 to the negative 2 equals 1 over 3 to the positive 2, right? That's just what the negative exponent is, 1 over 3 to the negative 5 is equal to positive 3 to the 5. Okay, so anyway, that's whatever. If you need help with that later on, I will help you. But that's the rule. You should know that. Okay, so now what is the power rule? What is the power rule? Jaylene, what's the power rule? Because now this is the exponent. What's the power rule say that I could do? Power rule. I lost my place here. There we go. Sorry. Jaylene, you looking it up? Hello? Jaylene Ruiz?
I don't know.
Wait. Jaylene, where are you?
Yeah, I'm
okay.
here.
Okay. Hey, I can't see you. I can't even see you. I just see Harvey Styles. Or what's his name?
Yeah, my camera, it works in the beginning, then as the meeting goes on, it doesn't work. It comes on and off throughout the thing.
See, I caught my daughter. This is why I like the camera. I caught my daughter sleeping while she was in class. I'm all, no. Are you sleeping or anything?
No.
Okay, very good. Jalen, then since you're not sleeping, look at the power rule that I had you write down. Take your microphone off, please. I'm having a conversation with you. All right. All right. So you looking at the power rule?
Yeah.
All right. What do you see there? Read it to me.
Is it the log BMN like equal to n log BM?
Yeah, what happened to that n there?
It got moved.
Yes. Which one of these looks like the n? Is it the 7, the 4, or the -1? Before it was moved. You have a 1 in 3 chance, Jalen. 7, 4, -1. Can you even see my board here?
I can see it.
Okay, which one do you think it
The
is?
4?
7? Try again. Where is the n? Let's see. Look at the 3. Do you see the 3?
Yeah.
Or the 2? Log 7, 3, 2. Do you see that
Yeah.
in your notes? Which one of these would be the 2?
The -1.
Yes, it's up there, right? And what did I do to the 2? If I
Moved
rewrote
it
it.
to the
Moved it where?
to the front.
Very good. So this will be log 7 to the 4th, right? Okay, very good. So this is log 7 to the 4th. Okay, now times -1 is what that's saying. Do you know what log 7 to the 4th is? Yes, it's 0.712. So it's -1 times 0.712. So my answer is -0.712. Okay.
Okay.
All right. You're not in bed. You're not laying down or anything, or eating, or eating or anything. You just have paper and everything. Write it out, Jalen.
Yeah, I have it all out.
All right. Very good. Okay. So let's go on to. Are there any questions? I can move on. Okay. Let's look at number 9. Okay. So we're using the properties here in number 9. Okay. Here. Look here. Look at number 9 here. Let me try to make it bigger. Can I zoom this? Okay, number 9. Is log 3, 6 minus log 3, 2? What do you think that equals? A, B, C, or D? I'm going to call on one of you. Log 3, 6 minus log 3, 2. Hint, subtraction, quotient rule. What does the quotient rule tell us that we're supposed to do? Jacob, what does the quotient rule tell us?
Divide.
Very good. Okay, so now that Jacob helped us with that, I want you to someone tell me if it's A, B, C, or D. I will call on you. No one yell it out. I'm going to call on one of you. Think about it. A, B, C, or D. Actually, I'll let you look at it for a little bit. A, B, C, or D. Basically, what is it? 64, 3, 12, or 36. Okay, time is up. But Sensei, I need more time. Gianna, what do you think?
B.
Very good. It's B, because 6 divided by 2 is 3. Let's look at number 11. 6 times log 3, 2. Okay? Think power rule. The power rule. Instead of bringing it down, we could bring it up. Okay? Which one do you think it is? I'm going to give you 30 seconds to figure it out. Log 364, log 33, log 312, log 336. A, B, C, or D? Number 11. Is it A, B, C, or D? And then, whatever your answer is, I'm going to ask you to explain it to me. Explain your answer. All right, time's up. Should I make time up? I don't know. Okay, number 11. Matthew, what'd you get?
Is it C?
How'd you get that? Oh, I know what you did. You multiply. You do in the power rule. What do you do with the 6?
Don't you multiply it?
No, but power rule. Matthew, look. Actually, let me write it down. Power rule says, well, here's the power rule. Put it here so we could see. Power rule, remember? Let's do it with the numbers. Log 7, 3 to the 2. I brought the 2 in the front, but I can also go backwards. Instead of having the 2 in the front, I can bring it on top there, right? I can go backwards. Right? So the 6 is here, so I can bring it up there. So so if I brought the 6 up here, can you see it, Matthew?
Yeah.
What would that be? 2, and what would the 6 be doing to the 2? It's not multiplying.
Is it 36? Or D?
How did you get that? I think you're on the right track. Just tell me how you got it.
2 times 2 times 2, 6 times.
Actually, 6 times will be 64.
Oh.
I think
Yeah.
2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Right. Yeah, so you just miscalculated, but you get it. Okay. That's all that matters. Okay, so I'm moving on to 13. Okay, expand the logarithm expression. So we're on 13. 13 is, so we just expand. Oh, dude, all you got to do is this, guys. Log 3, 4 to the x. You just go like this. Expand. What rule am I going to use? If it's 4 times x, what rule am I going to use? Roberto, what rule am I using here? 4 times x? What rule am I using? Roberto, can you hear me?
Oh yeah.
Mr. Sanchez.
Wait, who's talking to me?
Mr. Sanchez.
Yeah, what's up, Donna?
Can I go to the restroom?
Yeah, thanks for asking, man. You can just go next time. Just come back real quick. But thanks for asking. Roberto.
Yeah.
All right, there you are. Did you call Apple?
Well, I did this morning, but they haven't responded yet. It was like
all right, good job, good man. Roberto, what rule do I use here?
The
what? You cut out.
The product property.
Product rule, yes. So it'll be log 3, 4 plus log 3x. That's all you got to do there. That's it. Okay, 13. And then 15 will be like, 15, you use the power rule to expand it. And then, okay, 15. I'll do 15, then I'm going to stop. I'm going to move on. 15. Or do you guys want me to move on? Do you guys want me to skip 15? Speak up if you want me to do 15. Or otherwise, I'm going to move on. No one? Okay, I'm moving on.
For 15, don't you do the product rule and the power rule?
Yes, you got to do both of them.
Okay, all right.
Both of them.
Can you do it?
I'm kind of bored. I'm kind of like tired. Okay, so yes, do the power rule first because this 5 is up here. So we bring it down. log 5, 10x. That's the power rule. Then because I'm multiplying, I use the product rule. Make sure you keep the 5 there. Log 5 log 10 plus 5 log x. And that's all you got to do. That's expanded form. Okay. I'm going to leave it there for like 10 seconds. I'm moving on. Okay, time's up. No one said anything. Okay. So you guys, like this one, 17 is the quotient. Just do ln x minus ln 3y. Remember, natural log is just a base of e, right? This is a base of 10. It's still a log. This is just a different log. It's just log base e. They just write it a different way. Okay. Error. Let's look at this one. So make sure you do 19 on your own. 21. What's the error here? Log 2 5x. What's wrong here? I'll let you think about that. If you want me to answer it, you can ask me after class. Okay. 23. Condense. So this is just backwards, right? I'm just going to do 23 real quick and then move on. 23. Just one. I'm just going to do 23 once. 23 is log 4 7 minus log 4 10. Okay. What do you think my answer is going to be for that? Log 4 7 minus log 4 10. Log 4 7 minus log 4 10. What rule are we thinking about? You shouldn't need that much time to understand that. What rule are we thinking about? Taylor, what rule are we thinking about there?
The quotient property.
Okay, great. Do you have an answer there, Taylor? What do you think it would be?
I got log 4 7 over 10.
Perfect. That's it. No problem. All right. I'm moving on. So like a lot of these, right? So this one, you're going to have to do the product, the quotient rule. Like some of you have to just do like a couple of rules, right? You just have to do a couple of them, right? So let me do 27 real quick, just because you guys are probably freaking out about the fraction. I know you guys don't. Most people don't like fractions. Some people, you just got to appreciate the fraction, right? Well, if you don't like the fraction, what do you do? If you have a fraction and you don't like it, you know, what do you do to it? You do what you do to a gopher. You kill it. No, I'm just joking. Don't kill a gopher. I love gophers. I love them. You don't even understand how much I love gophers. Don't kill them. God's creatures. Okay, so the fraction, I can use the log 5 4 plus. I can use the power rule and put it up there, right? Power rule. Power. But then I can go like this. I can write it like that, right? That's all 1/3 means. And then using the product rule, I can change this to log 5 4 times cube root of x. That's condensed it. That's what I'm doing, like most of your homework for you guys. This is terrible. I'm like snowflaking you guys. You guys should be doing this on your own. Okay. Let's see. I'm just gonna do one more. Okay, you guys just think about all this stuff. Think about it. Think about it. I want to do the change of base formula here. Okay, change of base formula, 33. Real quick. 33 is log 4 7. Okay. Now, what that's saying is log base 4 7. Let's write that as log base 4 7. Hey, what does that equal? You don't have to write this down, but I just want to get an idea of what's going on. Let's write it as that's my base. Then I switch my 7 and my x. It's really asking, hey, what do I have to raise 4 to get it equal to 7, right? So anyway, let's do the change of base formula. I need a log base 10, so I go log base 10, 7 divided by log base 10, 4. That's all you do. So you do log 7 divided by log 4, and that's your answer. That's all you got to do. Kind of see my calculator better. Log 7 divided by log 4, and that equals 1.40. So if I raise 4 to the 1.4 power, it should equal 7 or close to it. Okay, that's it. Are there any questions? Here, let me leave it there so you guys can see. Are there any questions as people are writing this down?
Can you move it down a little bit? I can't see because there's like a light.
Like glare?
27.
Gotcha. I have that glare. It shines through my window. There you go. Is that better?
Yes, thank you.
You're welcome. Okay, are there any questions? Okay, I am going to leave this here for a little bit, so I can't see you saying goodbye to me, but I'll have a good weekend. You may go. I'll leave this here for like another 10 seconds, and I'm going to move it. But otherwise, see you later. Have a great weekend. Make sure you get your work into your check for understanding, and then you will be done. One more period to go. Bye. Bye. See you later. Bye. Bye. What, Kayla?
The third to last one that you did, can you show that one again?
Tell me what number that was.
I think it was 17. Did you do 17?
Nope.
No, then it wasn't 33. It was before. It was on a
Let me go
different
like
page.
this. Here's all the problems. I did 13, 15, 23. I did this one, 13.
It was 23.
Okay. Oh, that was pretty straightforward.
It's just that I didn't get a chance to write it down.
Oh, okay. It's the quotient, right? Yeah, it's good though. It's pretty straightforward though. It's a quotient rule. Log 4, 7 minus log 4, 10 equals log 4, 7 divided by 10.
Thank you.
You're welcome. All right. Any other questions anyone? Let's see who's there. I'm looking at you guys now. Okay. Any other questions? Let's see. Giovanna, I'm so glad your internet's working. Bye, Kayla. Giovanna, you have a question?
Yeah, I was gonna ask you if you could help me with number 17.
Yeah. Natalia, do you have a quick question or?
Yeah, I had a question about yesterday's homework.
Okay, well, let me do Giovanna's first, and then I'll do yours, okay?
Okay.
Okay. Listen, Giovanna, it's not that much different. It's the same thing. It's just looks different. For 17.
Mm-hmm.
It's just a log base E, which E is a number, it's log base 2.7. 17. Seventeen is the natural log of x over 3y equals the natural log of x minus the natural log of 3y.
Was that all?
Yeah,
Oh. Oh, okay.
that's all they want. Yeah, it's just because it looks like that ln is a natural log. It just looks kind of scary.
Okay. I see. Do we have to turn this in by today or is
No,
it
next Friday.
okay? Okay, thank you.
You're welcome.
Bye, Sensei.
All right, see you later. All right, Natalia, what question do you have?
It was number 55 from yesterday's homework.
Okay, 55. Let me look at it here. Hang on, I'm trying to. Okay, so 55 is asking us to graph a logarithm. Y equals log 4 to the x. Okay, so these look hard to graph, but they're really not. They look hard to graph like this, but let's put it in exponential form. I want to put the log on the left because it's easier for me to put in exponential form. It looks like that. Okay, so 4, and then switch the x and the y. So we really want to graph this. Okay, x equals 4 to the y. These are equal. All right, you with me so far?
Yes.
Okay, now the weird thing about graphing, I'm going to use a table. The weird thing about this is that normally the y is over here and the x is over here. So because it's backwards, what I'm going to do is I'm going to put numbers in for y, and that'll make my life a lot easier. And I'll put easy numbers in. So I'll put a -2 for y, because now I could solve for x. We're just going backwards. -1, 0, 1, and 2. Okay, so 4 to the -2. Am I going too fast, Natalia?
No.
Okay, 4 to the -2 is equal to 1 over 4 to the +2. Whoops, let me put it over here. Which is 1 over 16. 4 to the -1 is equal to 1 over 4 to the 1, which is 1/4. 4 to the 0 is 1. 4 to the 1 is 4. 4 to the 2 is 16. How are we doing?
Good.
Okay. So I'm going to do a table or a graph. Let's go by twos. 2, 4, 6. No, I'm going to go by fours. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. X, Y. Okay. So this says, now we're going backwards, right? So 1/16 is my X. So that means I go very short here for my X, and I go down -2. So right about there. Okay, and then 1/4 means they go over just a little bit more. They go down -1. And then X equals 1. Y is 0 would be right there. X is 4. Y is 1. Well, there, and then 16/2 will be somewhere over here. So, do you see how I got those points?
Yeah.
And the thing is, it's gonna go really close to this line here, not touching it. Then you go through your 2 points. It's gonna go up like that. It's gonna curve. And that is y equals log 4 to the x. So the key thing is to graph it, you put it in an exponential form and then plug in your y's.
Okay.
How's that?
Yeah, good. I get it.
Okay, cool. Any other questions?
Yeah, were we supposed to do 33, the word problem?
For today?
Yesterday.
Yesterday? Yeah.
Because I didn't know how to do the word problem either.
Okay. That one's actually not that hard too. If you look at it, I think if I explain to you, be like, oh, that's not that. Well, maybe it will be. Let's see. Maybe it will be hard, but it's all these words. It's just plugging in the equation. But let me read it. Skydivers use an instrument called an altimeter to track their altitude as they fall. The altimeter determines altitude by measuring air pressure. Okay, so there's a machine that measures air pressure. The altitude height in meters above sea level is related to the air pressure in pascals. Okay, so it's saying they measure the pressure in pascals. Okay, so they have altimeter that determines the height based on the air pressure. But whatever, that's not really the hard part. We just need to know this equation here. What is the altitude above sea level when the air pressure is 57,000 pascals? Can you see this equation right here?
Yeah.
Okay, so you just take that equation. I'm going to write it here for you to see. This equation, it says here, this number 33, the height is equal to -8,005 natural log, that doesn't matter, it's just a button on your calculator, pascals over 101,300. Okay, there's the equation. They say, how high is he at 57,000 pascals? Well, what do you think you're going to do?
Plug in 57,000 into P.
Yeah, that's it. Now, what's hard about that is because they had that equation there. You had to like kind of, it wasn't in the word problem. So that was kind of weird. 57,000. Do you want me to keep going or do you understand it now?
Can you keep going?
Yeah. What do you think I'll do next?
You divide it using the...
Yeah, so divide 57,000, divide that by 101,300. That gets 0.5. I got 0.562. And then that says I take the natural log in that. So then you hit the natural log. That's ln. See the ln button right there?
Yeah.
Hit that ln. I got to get that answer in there. And then you multiply that by -8,005. $4,603. So the height is 4,603.16 meters. How was that?
Oh yeah, that was a lot easier.
Yeah. Yeah, it's just a weird, I think it's hard to find that equation.
Yeah. Yeah.
All right.
That was it.
All right, cool.
Right, thank you.
All right, I'll see you later.
Yeah. Bye.
All right. Okay, bye.